Hey, this is Dr. Benton, and you are watching the lecture for April 23rd about storms. And this is something we've been leading up to all week, learning about air masses and weather fronts. And I'll be honest, I had fun creating this one, so I apologize if it's a little long. I'll try to go through it quickly because most of the information you need to know for your test we did talk about yesterday with weather fronts. Now we're kind of learning the fun stuff. So, warm-up question. How are thunderstorms made? Yeah, and then these are two GIFs. I don't know. Here we see a power pole, and there it goes. And this is actually a tree after it's been struck by lightning. Sometimes it'll just spiral and peel off the bark. In this case, it actually set fire to the inside of the tree. So these are both lightning events. Alright, so high pressure air masses in the middle tend to be clear and sunny. And that's because any kind of clouds or moisture in it evaporates as it sinks lower to the ground. So whenever we have a high pressure air mass, the clouds sink down and evaporate, leaving clear sunny skies. Low pressure air masses are the opposite though. Low pressure air masses rise, because warm air rises, it's less dense. And that allows the clouds to form. The water vapor condensates into clouds and then can eventually precipitate. So we tend to have rainy, cloudy weather in the middle of a low-pressure air mass. And then we also learned about weather fronts yesterday. We said that these cold fronts push the warm air up even more rapidly. So where we have a cold front, we have an even greater formation of clouds, and these are what form the thunderstorm clouds, these cumulonimbus clouds around a cold front. The warm front, on the other hand, is a little more gentle. It just kind of lays down slopes on top of the cold air mass, and that allows the clouds to really spread out. And they still bring rain, they're still condensating, but over a larger area for a longer period of time and less severe, less of a torrential downpour. So that's what you need to know for your test, the relationship between air pressure and air masses and weather fronts and thunderstorms. This is some other fun stuff that I would like to teach you though. First about cloud types, because I think I mentioned this once before. You can just look at the clouds and tell what kind of weather they're going to bring. And this is a good picture kind of comparing the size and shape of them. So when I say cumulonimbus clouds, I really mean that they're tall. They're huge. Clouds are not usually this tall. They're taller than they are wide. And it's really hard to see that from the bottom looking up. But these are very tall clouds. We call that vertical development. Compare that to the stratus clouds. They are low-lying. They are flat. Now we call this a nimbus cloud. Nimbus means that it's gray, full of rain. So this stratus is nimbostratus because it's gray and full of rain. This cumulus becomes cumulonimbus when it turns gray and full of rain. And these cumulonimbus clouds, we also said, are the thunderstorm clouds. Heavy rain versus just light rain from the stratus, nimbostratus clouds. Up higher in the sky is where we find cirrus clouds. The cirrus clouds tend to be wispier, lighter. They're much colder, so they tend to have ice crystals in them. And it's the ice crystals that gives them this kind of wispy appearance. If they go in front of the sun, it kind of makes this halo around the sun. And then what we see in the middle are kind of combinations of clouds. So it's a little bit cirrus and a little bit stratus. It's a little bit cirrus, but a little bit cumulus. It's a little bit stratus, but a little bit cumulus. And then these mid-level clouds, alto. If you're familiar with music, alto means high, but not the highest. It's typically the lowest female singing voice, or a high male singing voice. So alto, high but not the highest. And so middle, cumulus, middle, stratus. And we said that these cumulonimbus clouds are associated with the cold fronts. These nimbostratus clouds are associated with the warm fronts. Now, what makes a thunderstorm is thunder, lightning. And this is real, by the way. You can visit this article about them. They're using Tesla coils to send static electricity places, and it's actually pretty safe. This is how a lot of new wireless charging technology works as well. It's actually not new technology. Nikola Tesla invented it over a century ago. But long story short, it's coming back into favor. So electricity, there's a couple ways to generate an electrical charge. One of them is by rubbing, by friction. And that's what the moisture droplets inside a cloud are doing. They're constantly moving, blowing around, rubbing up against each other as they rise up and fall down. So it actually builds an electrical charge inside the cloud. As that charge gets bigger and bigger, it also induces the ground to carry a charge. And when both charges get big enough, they connect. And that's what we see as the lightning bolt. Lightning itself is over 5 times hotter than the sun. It only lasts for about 1/1,000,000th of a second, though. Very fast, very quick. But it's 5 times hotter than the surface of the sun, so it burns you that quickly, very immediately. We saw at the beginning the tree on fire because of lightning, and that's a real common cause of forest fires in nature, is just lightning. The lightning bolts themselves that we see are only about 1 inch in diameter. They look bigger because it's such a bright flash, but they stretch out for miles. Not just miles between the cloud and the ground, I mean across the ground, miles away from the cloud, they can travel. So lightning can be pretty dangerous. Typically, there's different kinds of lightning. A lot of lightning goes from cloud to cloud, so we don't really care about it. We see it, but we don't really care about it. If it hits the ground, that's what worries us. Sometimes it can go from cloud to ground, and that's how it's usually depicted, but that's usually more benign, less dangerous, less powerful. It's usually invisible. You don't really notice it as much. It's the return strike when I'm going from ground back up to the cloud that leaves that bright flash and that heavy thunder. And when lightning strikes, it can do it about 4 times in rapid succession, sometimes 19 or 20, I think they've seen, because of the advances in slow motion video technology. They can really pinpoint how much is happening in that split second. Lightning does use tall objects to reach the ground more easily, which is why during a lightning storm you need to avoid tall structures, tall trees, tall buildings. You want to go somewhere that's low-lying, preferably in a house or a car, because lightning will strike the house and go around you. And things like houses are made to be hit by lightning. That's why all the tall buildings have lightning rods on them, so that they do get hit by lightning instead of you. Now, lightning is the second deadliest weather event in the United States. Floods are actually the first, and we're going to talk about those at the very end. As you can see, Florida gets a ton of lightning deaths, and that's because of all of the low pressure that exists in Florida. It storms pretty much every day in Florida because of the competing land breezes and sea breezes. Here you see a burn caused by lightning, and it actually takes the shape of the lightning bolt because that's the shape of the electricity arcing through his body. And I could show you all a ton of online pictures. You can look them up yourselves. They leave these very pretty, I think they're pretty, burns. I'm sure they don't feel pretty. And if that happens inside your body, obviously it can be deadly. So a direct strike would definitely kill you. Being just like a couple feet away from a strike, maybe 10 feet away from the strike, you still get burned like this because of the little small discharges on the sides. So here's an experiment I saw online, and my wife says it absolutely works, so you should try it out too. Get you some Winto-Green Lifesavers, or Peppo-Mint Lifesavers, although I hear the Winto-Green works better. You go in the bathroom, you turn out the lights, and then you chew them with your mouth open. You keep chewing with your mouth open, you break up the Lifesaver, and you should see sparks appear in your mouth. And it's because of the same reason that lightning sparks in clouds. You're breaking apart the sugars, you're grinding them together, you're releasing those electrical charges. And when the opposite charges meet, it creates that spark. So try that out. Now, thunder is what we name thunderstorms after. Thunder is just sound, though. Thunder is just sound. It's harmless. It's the sound that electricity makes. You can imagine electricity in maybe comics, cartoons. It makes kind of a zapping or crackling noise. In this case, it's a way more electricity, like 1 billion volts. So it makes a loud crack, a loud boom. And we said that this is 6 times, 5 times hotter than the sun. And so all of that air being heated so rapidly causes it to burst, causes it to pop, kind of like a paper bag. And so that's what the thunder you hear is. Because it's so jagged, because it travels so far of a distance across the sky, if you're far away, you kind of hear it as a rumble over a few seconds instead of a instant crack. But if you been close to a lightning strike before, you know that it is just really one crack. Now, the light travels further and faster than the sound does. By the time you can hear the sound, though, you were close enough to that lightning that it could have struck you. Because sound dissipates after about 10 or 15 miles. Lightning bolts can reach 10 or 15 miles away from their cloud. You can be struck by lightning if you can hear the thunder. So if you hear thunder, you need to go inside and wait at least 30 minutes without hearing thunder. That's how you know you're safe. And if you're trying to count the seconds to see how far away that lightning is, that's a myth. Does not work that way. Because things slow down that sound. Things like mountains and valleys, things like trees, things like the leaves, depending on whether or not it's summer or winter. The sound is too variable. We can't accurately predict how far it is just from the sound. So if you hear thunder, you know that you're close enough to be struck and you need to find shelter. Now, when we talk about severe thunderstorms, we don't mean a certain amount of lightning or a certain amount of rain. We don't define severe by those properties. In order to be severe, you either have to have wind gusts greater than 58 miles per hour, which is pretty fast. You have to have hail greater than an inch in diameter, which is actually more common than you might think. And then if it forms a tornado, it's a severe thunderstorm. And we're going to talk about tornadoes next. But if they're calling it a severe thunderstorm, it has to have one of these things, either fast, super fast winds, or hail, or tornadoes. Otherwise, every thunderstorm would be severe if you just went by lightning, because that's how you define a thunderstorm, is that it has lightning, of course. So tornadoes are also caused by these thunderstorms. To understand what a tornado is, we're going to use the word vortex, because vortex is what you actually call this shape here. You've seen them when water goes down a drain, because they're very easy to make when water goes down a drain. It kind of spirals. And what that does is it allows the water to go down and the air to go up at the same time without bumping into each other. That's the vortex, this swirling shape so they can slide past one another. And so we see this like whirlpools in the water, but also water spouts if it's a tornado over the ocean. We call it a tornado if it's over land. And hurricanes are like giant vortexes. We call these tropical cyclones. Tropical cyclones, and we're going to learn more about hurricanes next week. But lots of examples of this vortex formation in nature, because it's a very efficient way for two opposing fluids to go in opposite directions. And remember, air is a fluid, it flows. Water is a fluid, it flows. So we see it in water and we see it in air. So tornadoes require very specific conditions to be formed. Tornadoes are caused by cold, dry air and warm, moist air. They don't mix. They want to skate by each other. But if the cold air is on top and the warm air is on the bottom, they're trying to slide past each other and can't. Cold air wants to sink, but the warm air is in the way. The warm air wants to rise, but the cold air is in the way. So instead, they start kind of spiraling and mixing with one another, especially if we have these strong crosswinds. So we call it a downdraft and an updraft. And then eventually, it usually starts as a horizontal tube, and then when it turns vertically, that's when we call it a tornado, when it hits the ground. And once it starts rotating like this, just like water going down a drain, it's not going to stop until it's all drained. It builds momentum with itself, kind of like a positive feedback loop. So eventually, though, all that air will equilibrate. The cold air goes where it needs to be, the warm air goes where it needs to be, and then the tornado will die down. But there's no telling when that'll be, how long it'll be. There's really no way to predict when or where tornadoes are going to hit. We do know the conditions that are favorable for tornadoes to form. It's impossible to predict, though, if a tornado is going to form. We rate tornadoes using the Fujita scale, nowadays an enhanced Fujita scale. We really define the categories based on wind speeds, but we identify the wind speeds based on the damage we would see. Because, you can't go inside a tornado to see how strong it is. A tornado is not going to hit the weather equipment. By the time you see a tornado, you can't just drive into it to measure the weather, measure the wind. But what we see is the aftermath it leaves behind. So with an EF0, 65 to 85 miles per hour, yeah, that's pretty strong. It might knock down a few trees, might take off some shingles, or if you have a weak building, it'll tear it down. EF1, we're talking about bigger things like garages, mobile homes, sheds, things that are a little more sturdy. By the time we get to EF2, it's tearing roofs off of even well-constructed homes. So not just the little trailers, but like regular houses like most of us live in. By the time it gets EF3, it's destroying those well-constructed homes. Just off the foundation, blows them away. EF4, it's now tearing apart brick houses. And we know that brick houses are stronger. If you've ever heard the Three Little Pigs, EF4 will tear apart a brick house. And EF5 will tear apart even concrete buildings reinforced with steel. It'll destroy pretty much everything it touches. So tornadoes are extremely destructive, but they typically only happen in a narrow piece of land, though. They can hurt one side of a street and leave the other half of the street untouched. They can make their way through a city, leaving a small line of destruction. And so tornadoes are different than hurricanes. We're going to learn more about the difference next week. And it's not that the wind that's blowing, it's what the wind is blowing. It's not that the wind will hurt you, it's that everything that it's blowing will hurt you. Because once these buildings snap apart and you've got these sharp wood fragments going everywhere, it is really easy to get impaled. That's the main reason you need to find safety in a low-lying area, so stuff like this will blow over you instead of into you. Now, more tornadoes happen in the United States than anywhere else in the world. We actually get 4 times more tornadoes than anywhere else in the world, the rest of the world combined even. And that's because we have the unique geographic features favorable for tornadoes to form. We have the special conditions that are required to make a tornado. They're especially common here in the Midwest. We call this Tornado Alley. We get the cold, dry air coming in from the Rocky Mountains. We get warm, moist air coming up from the Gulf of Mexico, and that leads just the perfect conditions to create the vortexes. So here you can see tornadoes, especially in Oklahoma. Oklahoma specifically is the tornado capital of the world. Texas has some hot spots too, throughout the Midwest. And you also see some red in Georgia. Georgia gets a fair number of tornadoes every year. There was a tornado in Cartersville not too long ago, maybe a week ago. Killed a person in their sleep. A tree fell on their house. So tornadoes happen here too. But even though we have a lot of tornadoes, most of them are very small. Most of them happen in rural areas. Like, people are very spread out here. What really kills people are floods. Some people think that a flood is just water rising out of a river. No, that water moves. When it happens very rapidly like this, we call it a flash flood. And you see it's powerful enough. It's not that high, but it's powerful enough to move so much debris with it. All of these heavy limbs, all of these tree trunks with it. So a flood is simply water overflowing onto land that's usually dry. That can happen from rivers, that can happen on the coast, that can happen over a low-lying drainage basin. It can happen in the middle of cities. And when it happens quickly, like minutes to hours, we call that a flash flood. And all floods are about 2 things: water in versus water out. If we have too much rain in too short a time, it's going to overflow. The ground's not going to be able to soak it up fast enough. The sewers aren't going to be able to drain it fast enough. We can't get it out of the way fast enough, and so it builds up. And so that lack of drainage really contributes to flood formation, especially once the ground gets fully saturated. No more water can infiltrate and soak into the ground, so it just has to run off. So when we have the movement of floodwaters like this, it affects many miles away, like 50 miles away from where the actual weather is. So hopefully you were listening to the radio and you hear that there's a storm far away that's bringing a flood your way. A lot of people don't receive that news, though, and so they get caught up in floods like this, and that's why it's the most deadly weather-related event in the United States. And this is also the number one way that hurricanes kill people is by flooding, and we're going to learn more about hurricanes next week, I said. Over 2/3 of the people who die because of floods do so in their vehicles. They see the puddle, they try to drive through the puddle. They get trapped in their car stalls, the engine stops working, they can't get out, maybe their electric door locks no longer work. Maybe the water actually sweeps them away. If it sweeps you into a wall where you can't open your car door, you can no longer escape, you're trapped. Maybe you were sitting in an area here that's only a few feet deep, but it pushes you into an area that's now 10 feet deep. You're now way underwater in your vehicle, and you can't get away. So 2/3 of weather-related fatalities in the United States are due to people driving through puddles. Just don't do it. Don't drown, turn around. If you see running water across the roadway, it's almost impossible to predict how deep it truly is from inside a vehicle. If it's 6 inches deep, that's all it takes to carry a person away. It'll knock you off your feet because water is way more powerful than wind is. If you have a normal-sized car, it can only take 12 inches. So by the time it reaches your bumper, it's powerful enough to sweep you away. And even the biggest trucks, 2 feet is all it takes to sweep them away. So again, not much higher than their bumper, and they're getting washed away by these floods and killing people. So if there's a flood warning, get to higher ground, do not drive into the water, and stay informed so that we can figure out where this water is coming from and where it's going. Now, it's important to know the difference between a watch and a warning when we're talking about these weather-related events. A watch means that the conditions are favorable. It means that it can happen. Not that it is happening, but that it can happen. This severe thunderstorm could develop. It can produce tornadoes, or it can produce hail, or it can have high wind. If it can produce a tornado, we have a tornado watch. That means you can form a tornado. A warning means it happened. A warning means, yeah, it's making tornadoes. There's a tornado. I see a tornado. There's a tornado. Severe thunderstorm warning means, yeah, we've got the heavy winds. Yeah, we've got the hail. So by the time you hear a warning, that severe weather event is already occurring. Hopefully not right on top of you. Hopefully it's somewhere to the side of you so that you can prepare yourself, brace for it. But you've really got to pay attention to these watches and warnings so that you know when and where the weather's coming. So I spent all day looking at weather-related YouTube videos. There's a few I want to show you now. There's a lot of them I'm going to show you during that Zoom conference on Thursday. Today, I guess, is when you're watching it. So 1 p.m., be here. We're going to see tons of video clips of floods and lightning and tornadoes. Fun stuff. But let's take a look at these 4 videos because they kind of explain these phenomena a little better. This first video is by National Geographic, and they're going to teach us what a thunderstorm is, how they're made.
Off on the horizon, they rumble. Rolling across the land, they darken the skies, and spark fire in the darkness, letting out an unmistakable roar. Thunderstorms are rain showers accompanied by lightning and thunder. While violent, these weather phenomena are common, with about 2,000 occurring at any moment worldwide. There are 4 major types of thunderstorms. Single cell, which are small, weak, and isolated storms. Multi-cell, a common type of storm that includes... Off on the horizon, they rumble. Rolling across the land, they darken the skies to then spark fire in the darkness, letting out an unmistakable roar. Thunderstorms are rain showers accompanied by lightning and thunder. While violent, these weather phenomena are common, with about 2,000 occurring at any moment worldwide. There are 4 major types of thunderstorms. Single cell, which are small, weak, and isolated storms. Multi-cell, a common type of storm that includes a cluster of thunderstorms. Squall line, a collection of storms that can form a line hundreds of miles long. And supercells, the most intense kind of storm capable of producing tornadoes.
All thunderstorms form when warm air in the lowest layers of the atmosphere rises. Called an updraft, this air causes water from the Earth's surface to evaporate and carries the moisture upward to form clouds. The clouds then build and grow, sometimes as tall as 10 miles high. The clouds darken as they fill and become heavy with water. Cool, dry air from the upper layers of the atmosphere, known as a downdraft, then pull this moisture downward, causing it to fall as life-sustaining rain. In addition to helping sustain life, thunderstorms also help maintain the planet's balance of energy and electricity. When energy, specifically in the form of heat, causes water to evaporate, the heat is carried upward with the water vapor. As the vapor condenses and forms water droplets, it releases the heat into the higher altitudes of the atmosphere and cools the Earth's surface. Thunderstorms also help regulate the electrical balance between the atmosphere and the planet. As clouds in a thunderstorm develop, excess positive and negative charges form within them. At a certain point, this buildup of opposite charges leads to the transfer of electrons in the form of lightning. This transference of electricity occurs so quickly that it breaks the sound barrier, a phenomenon that produces...
Good. So hopefully that was a basic explanation about thunderstorms that we've already heard. So the warm air rising that makes them so powerful. We also talked a little bit about electricity here. And again, electricity is not really going to be on your exam. It's just for fun. I think electricity is fun. We have a separation of charges. And when you have a separation of charges, it creates an electrical current as they flow back towards one another. And in this case, we have a current between the clouds and the ground that will zap between the two. And when it does, it creates that lightning, that thunder that we hear as characteristic of a thunderstorm. This is our next video. It's a storm chaser. And storm chasers, some of them know what they're doing. The vast majority of them are morons with a camera. This guy seems to kind of appreciate the danger involved, though, and isn't just doing it for kicks, the way people like skydive for fun, you know? He's doing it for a reason, because people do need to know when and where the tornadoes are happening.
They call me the tornado chaser. When the wind is up and conditions are right, I get in my car and follow violent storms. Crazy, you say? Perhaps, but really, I chase these sky beasts to learn about them. I want to share with you what I know. Tornadoes are rapidly rotating columns of air that form inside storms, then connect with the ground via a funnel of cloud. When that happens, they tear across the earth, posing a huge threat to life and property. Because of this, there's a great deal of research into these phenomena. But the truth is, there's still a lot we don't know about how tornadoes form. The conditions that may give rise to one tornado won't necessarily cause another. But we have learned a lot since people first started recording tornadoes, like how to recognize the signs when one is brewing in the sky. Are you coming along for the ride? Tornadoes begin with a thunderstorm, but not just any thunderstorm. These are especially powerful, towering thunderstorms called supercells. Reaching up to over 50,000 feet, they bring high-force winds, giant hailstones, sometimes flooding, and great flashes of lightning, too. These are the kinds of storms that breed tornadoes, but only if there are also very specific conditions in place. Clues that we can measure and look out for when we're trying to forecast a storm. Rising air is the first ingredient needed for a tornado to develop. Any storm is formed when condensation occurs, the byproducts of the clouds. Condensation releases heat, and heat becomes the energy that drives huge upward drafts of air. The more condensation and the bigger the storm clouds grow, the more powerful those updrafts become. In supercells, this rising air mass is particularly strong. As the air climbs, it can change direction and start to move more quickly. Finally, at the storm's base, if there is a lot of moisture, a huge cloud base develops, giving the tornado something to feed off later, if it gets that far. When all these things are in place, a vortex can develop enclosed by the storm and forming a wide, tall tube of spinning air that then gets pulled upwards. We call this a mesocyclone. Outside, cool, dry, sinking air starts to wrap around the back of this mesocyclone, forming what's known as a rear flank downdraft. This unusual scenario creates a stark temperature difference between the air inside the mesocyclone and the air outside, building up a level of instability that allows a tornado to thrive. Then, the mesocyclone's lower part becomes tighter, increasing the speed of the wind. If, and that's a big if, this funnel of air moves down into that large, moist cloud base at the bottom of the parent storm, it sucks it in and turns it into a rotating wall of cloud, forming a link between the storm that created it and the earth. The second that tube of spinning cloud touches the ground, it becomes a tornado. Most are small and short-lived, producing winds of 65 to 110 miles per hour. But others can last for over an hour, producing 200-mile-per-hour winds. They are beautiful but terrifying, especially if you or your town is in its path. In that case, no one, not even tornado chasers like me, enjoy watching things unfold. Just like everything, however, tornadoes do come to an end. When the temperature difference disappears and conditions grow more stable, or the moisture in the air dries up, the once fierce parent storm loses momentum and draws its tornado back inside. Even so, meteorologists and storm chasers like me will remain on the lookout, watching, always watching, to see if the storm releases its long rope again.
If you see a tornado, run. Tornadoes can move at about, at a maximum, I think they've clocked them at 60 miles per hour across the ground. The wind speed inside, of course, 200 miles per hour, but they can move 60 miles per hour towards you, and you cannot predict their path. You don't know if it's going to go left, right, straight. There was one safety video I was going to show y'all. I don't think this is it. So this video is actually from Business Insider, not YouTube. It's an article about why there's so many tornadoes in the United States, why there's like 4 times more than the rest of the world combined. And they do a good job explaining this tornado phenomenon as well.
Each year, America gets around 4 times as many twisters as the rest of the world combined. Taken all together, countries outside the US see around 200 to 300 twisters annually, compared to more than 1,200 that strike American soil. So what makes the US so special? To make a tornado, you need just the right mix of ingredients. Warm, humid air near the ground, cold air higher up in the atmosphere, and wind that overlaps while moving at different speeds or directions. Believe it or not, few places on Earth check all of these boxes, and none compares to the Great Plains of the United States, also known as Tornado Alley. And that's largely thanks to this, the Gulf of Mexico.
The Gulf of Mexico is actually the warmest body of water on Earth at its latitude.
And when it comes to making tornadoes, the warmer the air, the better. As hot air rises off the Gulf, it crawls north across the plains, where it meets air blowing west out of the American Rockies. And when the two come together, they can create a vortex of wind that spins horizontally. Now here's where that warm air is key. As it rises, as warm air likes to do, it tilts part of the tube vertical to form a rotating storm called a supercell. And up to 20% of those supercells spawn tornadoes. Now, you can find these conditions elsewhere in the world.
So anywhere where you can find warm water that's equatorward of some area that also finds itself downwind of a major mountain chain, tornadoes have an elevated risk, I would say.
Take Bangladesh, for example. Warm, humid air spreads from the Bay of Bengal and travels north, where it overlaps with winds blowing southeast out of the Himalayan mountains. This produces an average of around 6 tornadoes each year, including the world's deadliest, which struck in 1989. It killed 1,300 people and injured another 1,200 more. But 6 tornadoes a year doesn't even come close to the 1,200 we see each year in the US.
My goodness. That is a thing of beauty.
And tornadoes don't just strike the US during tornado season from March through June. In January, for example, we get about 36 of them. That's because you can find those perfect tornado conditions year-round, and over a region several times the size of Bangladesh. But that said, tornadoes are probably not as common in the US as you think.
Most people greatly overestimate how often tornadoes occur in Tornado Alley. If you watch the movie Twister, it's easy to think that every day at 4 o'clock they sound the alarm and you just go underground. That really, most people who live in Oklahoma have never seen a tornado before.
That's because even in Oklahoma, the tornado capital of the world, these storms only strike the same spot once every 1,200 to 1,500 years on average. Tornado winds can reach a whopping 400 kilometers per hour, plenty fast enough to sweep you and everything else off the ground.
And another reason you don't see a ton of tornadoes in your lifetime is because you're not supposed to be outside if there's a tornado. You need to go inside. There it is. So they tend to talk about Tornado Alley being these states, and they're right. And historically, they've come into Indiana and Ohio as well. During the winter months, though, it's us southern states that seem to get the brunt of it. And this is something I've noticed getting worse in recent decades. I don't know if it's a real thing or not. I might have just been looking at bad maps. But it seems like we get a lot of tornadoes as well. So it's definitely something you want to be aware of, and definitely something you want to worry about if you hear one's happening.
That's because you can...
Alright, and this last video is on YouTube. It's about floods. It's also from National Geographic, same as the first video we watched. I had a lot of trouble finding a good video that explained floods, because mostly what you see is floods in action, and I really think that's the best way to explain these. Because floods aren't just like swimming pools that rise up. Floods are more like a wall of water, kind of like an avalanche or a mudslide of water. Is the best way to describe it. So when they hit you, they're flowing very fast and very hard.
Over the past 100 years, no other natural disaster in the U.S. has caused more death and destruction than floods. They can happen any place, any day, any time. And they will likely only get worse. As people cluster around coastal regions and floodplains, our growing population will confront the awesome power of water. For thousands of years, farmers have depended on seasonal floods. The waters irrigated their crops and fertilized their lands. Today, excess water is channeled into reservoirs and power hydroelectric dams. But when water levels rise suddenly, far more than the ground can absorb, a flood occurs. Flash floods are a perfect example. Sudden storms unleash a torrential downpour. The runoff moves with surprising force. At a depth of 2 feet, the water can push aside a car. In fact, half of all deaths from flash floods involve vehicles. But floods occur in many other ways. Heavy rains and thawing snowfall can overwhelm rivers. Storm surges caused by hurricanes and tsunamis inundate the coastline. Landslides and mud flows can displace large volumes of water. Dams break, levees fail. In the Great Mississippi Flood of 1993, several of these factors came into play. Over 10,000 square miles of the Midwestern United States were overwhelmed with rain. In a cruel twist, the earthen dams known as levees along the upper Mississippi River forced the water to flow downstream faster and stronger. Communities further downriver were hit with the full brunt of the Mississippi. 2/3 of all the levees were breached. Though towns rallied to protect their lives and livelihoods, the damage was still immense. Over $10 billion in damages, 56,000 homes flooded or destroyed, and some 50 people were killed. At the start of this century, another powerful flood wreaked havoc, this one coming from the sea. The storm surges of Hurricane Katrina submerged 80% of the city of New Orleans. Over 1,800 people died in the floods. The damage has been estimated at over $80 billion. In some ways, the New Orleans disaster was unique. Much of the city lies below sea level, and despite years of warning, the city was woefully unprepared to handle a breach of the levees which kept it dry. But we are still vulnerable. Sea levels may rise, coastlines could erode, rain patterns might change, snowpacks could melt, and then the waters would rush in.
Yeah, so Hurricane Katrina was still a little before your time, but you might have heard about it. It was devastating because the city is built in kind of a bowl that's 10 feet below sea level. So we said that floods are too much rain in too short of a time. It needs time to drain out. There's literally nowhere for this water to drain to. There's nowhere for it to go. They have pumps that help pump it out to nearby lakes and rivers and such. The pumps failed. They had walls called levees to help keep the water out. The levees broke. And so the city got flooded, and there was nowhere for that water to go. A lot of people died. So those are the weather videos I wanted you to see for sure. I also want you to come check out these other awesome videos today on Zoom if you get a chance. I'm gonna try to record it. I keep trying to record them, and it's not working. But anyways, I'll try to figure it out this time. So take it out the door. Most of this learning here is optional. You need to know how the thunderstorm is made. You don't need to know anything about lightning or tornadoes. But let me ask you, what is your favorite extreme weather event? We talked about lightning and tornadoes. We also talked about flash floods. We're going to talk about hurricanes. And of course, there's several others that I haven't even mentioned. So tell me, which one do you think is most interesting and why? I really like lightning. I think it's pretty to watch. So this is a quote. This is probably also before your time. A comedian, Ron White, and most of his jokes are rated R, so you might not have heard of him. But they evacuated everybody from the Florida Keys, and everybody leaves except for one guy who's going to stay there and tie himself to a tree on the beach to prove a point. And the point was, he said, that at 53 years of age, he was in good enough physical condition to withstand the wind and the rain of a Force 3 hurricane. Okay, let me explain something to you. It isn't that the wind is blowing, it's what the wind is blowing. If you get hit with a Volvo, it doesn't really matter how many sit-ups you did that morning. And I think that's a great quote for weather disasters, because with floods, it's not that you can drown, it's that the water itself is poisonous, it's toxic. It's not just that the wind of a tornado will take you off your feet and blow you away, it's that all this other stuff can come and impale you. So when it comes to weather, be safe, use common sense, and hopefully I taught you some more common sense today. Thank you for joining me.